Hello student, today we will see the 4x4 keypad interfacing with the PIC microcontroller. This is the interfacing diagram of the PIC microcontroller to the 4x4 keypad interfacing, and whatever the pressing the key we can see on the LCD. So here we are connecting a LCD also. So RB0 correcting column 1, RB1 column 2, RB2 column 3, RB3 column 4, then RB4 R1 row 1, RB5 R2 row 2, RB6 row 3, RB7 row 5. This is the column and row matrices 4 into 4. Okay, then same as it is the LCD display connect to the microcontroller like reset, read, write and enable pin to RC3, RC4 and RC5, and all data pins D0 to D7, 8 data pins are connected to D0 to D7, and the all necessary power supply VCC and ground are connected. Okay, now let's see the code for the 4 into 4 keyboard interfacing and also 16 into 2 LCD display. So here we are, the first point we are initializing the including the .h file, which is the pic.h file, that is the P18F4520.h file. We are including that .h file. Then again here we are not writing again LCD program, but we are including the .h lcd.h file here, hash include lcd.h. Okay, now we are configuring the some pin 5 to 6 pin. We are configuring, we are initializing of, we giving the disable to some pin. So here first we are making the high to the external crystal oscillator. The OSC is equal to H. Okay, so this one, then we are again the second one here, the PWRT we are making off, that is a power up timer display disable after the PIC microcontroller get power and it start the running the program immediately without waiting. Then WDT is equal to off means watchdog timer disable, means watchdog timer is a hardware timer built into microcontroller that automatically reset the microcontroller unit. Then debug off and LVP off, it means the debugging and low voltage programming disable. So it is a, here we are the two pins are disabled. Then we are doing the function, writing the function of delay, void delay unsigned int I times. Okay, now next part is the, this is the whole part is the initializing the pins. We are declaring the pin. So 4 by 4, 4 rows 4 column we are connecting. So RB0 to RB3, these are the 4 row, and RB4 to RB7, it is a 4 column we are initializing. Then we are displaying on the LCD, what we are displaying, unsigned character text 1, the first line on the display, Loxon system. Then unsigned character text 2, the key press. Okay, here we are displaying the two lines, first line and second line. Okay, now main function void main void. So TRISD 0x00, it means the we are making port D as a output. So here we are connecting the LCD. Then TRISC, so 000 0x00, we are making the port C as a output. Here we are connecting the LCD control lines. Then ADCON1 is equal to 0x0f. Here we are configuring the analog pin as a digital input output. So disable the ADC or relevant pins. Okay, so then next here TRIS B bits is equal to 1. Here RB0 to RB7 we are connecting the row 1, row 2, row 3, row 4 and the C1, C2, C3, C4. Here where RB0 to RB3 are rows, input and RB4 to RB7 are column, it is a output. Okay, here we are connecting input and output. Okay, 1 means input and 0 means output. Okay, here we are configuring the port B pin directly. So LCD initialization, LCD display, LCD display to LCD initialization, we are initialize the LCD. Then here we are display the text 1. Here we are display the text 2 on row 2. Then while loop, it is a continuous infinite loop. Then scan column 1. Now we are doing the keypad programming. Here we scan the column 1. So C1 is equal to 0. It means that column 1 low, active. The C2, C3, C4 at that time is equal to 1. It means the column high. These columns are inactive. So now check each row input. If the row reads 0, it means the key at row column 1 is pressed. Now if R1 is equal to 0, if see R1 is a low while column 1 is a drive low, so key at R1 C1 press. Okay, that's mean LCD data F, display character F on a LCD. Okay, then if R2 is equal to 0, it means R2 is a low, so R2 C1 key, so LCD data B is a display. Then if R3 is equal to 0, row 3 is equal to low, R3 C1 is equal to RC C1. So LCD 7 display. Then R4 is equal to 0. That time R4 and C1 is we are pressing low. So LCD display 3. Like that for column number 2. Okay. C2 is equal to 0. Here we are making the C1 is equal to 0. Other are 1. So here now C2 is equal to 0 and other ones are 1. So C2 is equal to 0 active and the other is a high. C2 is equal to low and all are the high. Again same concept. R1 is equal to 0, display E. R2 is equal to 0, display A. R3 is equal to 0, display 6. R4 is equal to 0, display 2. Okay. Then next column number 3, C3 is equal to 0. Other all columns are 1. So here R1 is equal to 0 means display D. R2 is equal to 0, display 9. R3 is equal to 0, display 5. R4 is equal to 0, display 1. Then scan for the column number 4. This is the last column, 4 by 4. So C4 is equal to 0, C1, C2, C3 is equal to 1. Here same as it is. R1 is equal to 0 means display C. R2 0 means display 8. R3 0 means display 4. R4 is equal to 0 means display 0. This is the whole keypad. Then this is the we are scanning column 1, column 2, column 3. It is a end one full scan cycle. Repeats continuously updating display character for the while loop. While loop is continuously displaying. This is the main program for the display 4x4 keypad interfacing with PIC microcontroller. Thank you so much. If you like the video, please share, please like the video, subscribe the channel and share the video.